Hello. I think everything's working now. Can you hear me? Do you see the desktop? Does everything seem right? Do you hear me?
Yes, sir.
Oh, okay, great. Thanks. Okay.
Sorry, I just got back to my mic.
Okay. Yeah, thanks. Okay. So looks like almost everyone's here. Okay. All right. I got the chat window up. Okay. Now, let's see. Is anybody getting, let's see, with the homework assignment is due Monday. Anybody got any question about the current homework assignment?
Hopefully, I will have some tomorrow for your office hours.
Okay. Yeah.
I'm get,
Remember you're adding operators.
yes, five operators, I
Yeah.
think.
Okay. Yeah, we're gonna go through the evaluator again today, but we're gonna do language 5. So we'll step through the idea of the evaluator again today. We did 4, yeah. So we'll review those ideas again a little bit. We'll see more example of an evaluator today. Okay. Anybody any question? Anybody got a question about the second homework assignment? Okay. All right. So we've been talking about local variables, okay? And language 4, look, remember language 3 was only global variables. Language 4 had local and global variables, been kind of a not very elegant way. There's something, it's not the language 4 is in a way that very few programming languages be set up. Some are that way, but not very often. And language 5 is much more in the direction of what a real modern programming language does. So like, remember, whoops. Oh, I got those links broken. Let's see, what is it? I didn't test them. Let me see what's wrong with that link. I probably forgot to copy the folder up there. Oh yeah, the folder for the 8th is missing. So I forgot to copy that folder up there. Okay, so let me make a copy of it here. Okay, so remember, we were talking about things like this. Yeah, if you have a variable and then in another scope, you redefine what does that do? Yeah, should it give this guy a different definition or should it create a new variable? This one clearly will create a new variable, but that variable should die when you get to the end of the block. But it's not so clear whether this one should change that one or if this one should create a new variable. So there's an ambiguity here. And we saw that you can design language 4 either way. You can make it so language 4, when it sees this, it says, oh, there's already an X, so I'll update it. Or you can make language 4 saying, well, I'm in a new block, so that's a new X. And then when you get back here, you're back to the old X. Okay, so this could be the same X, or this could be a new X. Okay, so the way we're going to solve that is with some syntax. We're going to make clear. So what we're going to do is we'll take a program like this, and we're going to add some syntax to it. So you would say there here, okay? And then here, you could either say there, or you can say set. Now, if you say set, that means set X to 1, that's this X. So then you have a syntax to say, oh, I want to update the current X. But if you do there, you're saying I'm creating a new variable. So in this scope, I'm creating a new variable. Okay, and then this one set here wouldn't work because there is no Y, so that would be an error. But you can say there here. Now, if this was Java, you wouldn't use var and set. If this was Java, it would look like the following to distinguish these. If it was Java, you would say int x, that declares x. Since there's no declaration here, then you're by definition updating this one. On your hand, if this was Java and you wanted a new variable, then you'd say what data type it is. So you use the type. And in fact, you could change the type. You could say double x here, and then this x hides that x, but it changes the type too. This is a double x, not an integer x. Or you could even put a Boolean there. Okay. So, but there's a syntax. If you do that, then that means update the current variable. Okay. If you do this, you're declaring a new one. Now this one, there is no y to update. So well, let me put this back to int. Since there's no y in existence, you have to declare a new y there, but then it's in this scope here. So y goes up to here. Now again here, well, here you can't redeclare x in Java. Okay, so you can't do that now. That would be a redeclaration of x. Since there already is an x in that scope, you can't redeclare it. So now you would stick with this. Okay, so that's what we're going to do. We're going to distinguish. We're going to declaration from, well, this would be, that's a declaration. This is what we're going to call assignment. So we're going to distinguish between declaration, and in our language, declaration will be var keyword. And then, so this would be the var keyword. And then this would also be a declaration here. That would be the var keyword. Then this one's going to be assignment, and in our language, that's going to be the set keyword. And if you put set here, that would work, but then that would change that one to assignment. Okay, so now with a set there, that one is assignment, and it's assigning to this guy. Okay, so we're going to have var and set. Java has, in Java, you do the declaration with a type, and you do assignment without any type. Okay, so in Java, you use a type to declare, and if you want to do assignment, then you don't have the type. Okay. Okay. I think in JavaScript, you declare a variable with var, and like in C, if you want to do assignment, you just do that without the keyword. So this would be declaration. In JavaScript, that would be declaration. This would be assignment. Okay, there is no set. I don't think, if I remember right, there isn't a set in JavaScript. Some languages have a set, but I think JavaScript has var for declaring, but then the trouble is, the JavaScript is a messed up language because here's the console for JavaScript. You can do a lot of things in JavaScript. I have a variable x. See, it's 1. Then I can do var y equal 2. Now I have a variable y. It's 2. I can do let z equal 1. Notice I've got a variable x, a variable y, and a variable z, and I declared them 3 different ways. And I'm not done. I can declare it a 4th way. Okay, notice I've got x was declared without any keyword, y was declared with the var keyword, z was declared with the let keyword, 4 was declared with the constant keyword, the language has got an idiotic, ridiculous number of way of creating variables, and they are unfortunately all slightly different. For example, W can't be changed. The const keyword means that W cannot be assigned to. See, because I declared W constant, I can't assign anything to W. So that's one thing that makes that different. Constant's a way of declaring a variable, but then its value is constant. It can't be changed. I don't remember the difference between var and let. I forget how they, var is one thing, let is another thing. Oh, and then assignment. Now, notice that this declared a variable x, but if I go to y, if I want to assign to y, I just use x. See, now y is 12. So here, this was assignment, but here it was a declaration. Okay, same. Now, what about the z? If I do z equal, say, 45, see, z's been updated. So the var and the let can be assigned to with an assignment, but then, like, down here, if I just say Bob equal 89, I got a variable Bob now. Okay, but I didn't declare it, but the variable exists. This Bob is not the same as the Y. I can't remember now what the difference is, but you've got 1, 2, 3, 4 ways of declaring variables in JavaScript. And what it is this one came first. They realized that there was a problem, so they created this. It still wasn't very well designed, so they decided they created this. So as the language has grown, it's absorbed new ways of declaring variables. And if they were to go and redesign the language from scratch, they would probably get rid of this, and they would probably get rid of this and keep the let seems to be the more modern way. I think let is the current modern way to write JavaScript. And I think var is considered a little bit old-fashioned, and this is considered old-fashioned. And constant goes along with let. So the new way are this if it's a variable, and this if it's a constant that doesn't change. Okay, so it's got 4 ways of creating variables. Okay, 4 ways of creating variables, and then a way of updating the variable. Okay, so we're going to have just 2 things. You either declare a variable or you update a variable. That's the way a language should be. There should only be 2 things you could do. You can instantiate a new variable with a declaration, and you can assign to an old variable. There should be 1 way to create a variable and 1 way to assign. Now, it is kind of good to have maybe constant. Okay, so that creates a variable that can never change its value. That's not a bad idea. Separate this, this is a variable, so it can change its value, and this is a constant that can't change its value. So that could be added to our language. That wouldn't be a bad thing to add to our language, have variables and constants. And then constants, that that they can't be changed. Okay. So, and in many programs, having something that you explicitly say cannot change values is useful. Makes it a little bit easier to read a program when you know that this thing's not a variable. It's just a name for 4 and it can never change. That can make it easier to maintain programs and to write programs. Okay, so having a distinction between variable and constant, that would be a nice feature to add to our language. Okay, so 1 way to create a variable that's a variable, 1 way to create a constant, and then 1 way to update the variable, and you can't update the constant. JavaScript, an insane language. JavaScript is notorious for having been designed in piecemeal over the years in kind of ad hoc ways. And so now you've got 1, 2, 3, 4 ways of declaring a variable that are all slightly different. The only one that makes sense is this one. Okay, that creates a variable that doesn't change value. But this and this are confusing because they don't act alike, and I do not remember offhand how they differ, but they're not the same thing. And then this guy is not like either this one or that one. And you're not supposed to do this anymore, but you can. The language allows it. But to create a variable by just naming it, like I did down here. Okay, Bob is 89. To just create a variable by assigning to it, that creates the variable, is considered very bad style at this point. Okay, that's the way the language originally was designed when it very, very first created. Now, Python also has similar problems to JavaScript. because Python also has a whole bunch of ways of creating variables, including this guy, where you just, by assigning a value to a variable, you create the variable. So just, just creating a variable ad hoc like that. You know why that's a bad, does anybody know why that's a really horrible idea? Python and JavaScript let you create variables just by assigning a value to a name. Okay. Why is that really considered a bad idea? You guys have been programming enough. You should be starting to build up a sense of what's going on here. That's considered really horrible.
Yeah, if you change it to a different type later on, like from an integer to a float.
No, that's got nothing to do with this.
No.
No, because if I do var x equal 6, then later on I say x equal true, that's got nothing to do with how I declared it. Yeah, that's bad. You're right. That's bad, but that's not the issue here. The issue here is that you can just create a variable by just naming it. Why is that really bad? That you can just create a variable just by giving it a value.
Well, that just means you have to pay more attention to the value you're assigning to it.
No, that's not the issue. No.
Because it's going to determine, it's going to interpret the type from the value you give it.
That's not the issue. That's not what's wrong here. I work for Microsoft and I like very complicated names. Okay. Millions of lines later, I need to update a variable. So I like very complicated name. What's the bug?
Well, aside from the capital letter.
What's the bug? This is in one part of my code, and a million lines later, there's this.
Well, I see two things. It's the top one's missing a P, and the bottom one, the N is.
What's the bug, though? Okay, yeah.
You're going to get two different instances.
Right. Where you think you're updating this variable, you're creating another variable. And the compiler says what?
Nothing.
Nothing. Yeah. See, that's the danger. If you accidentally misspell a variable, you just created a new one. See, now if I do this, now that's an undeclared variable in Java. So, the compiler flags it, undeclared variable. Because in this case, it would be because that thing is lowercase. I think that's the only change I made, right? Did I get everything else right? And
Yes, once you put the P in the upper one, that was the only thing.
Yeah, right. Okay, but see, in Python, you've got a really hard to find bug now. Do you know how Python solves this problem?
No.
You run your program through a linter, which looks for these kinds of mistakes. And the linter says, wait a minute, you got a variable on line 57 and another variable on line 138, and they look a lot alike. Did you mean them to be the same thing? That's called a linter. It looks for weird things in your program. Why is it called a linter? JS lint. Why is it called a linter?
I forgot.
What's lint? What do you think?
The stuff in your bottom of your pocket.
Right. It's looking for stuff in your program that shouldn't be there. Programmers like puns. Programmers like to make jokes. So you're looking for lint in your program, stuff that shouldn't be there. Okay. The lint goes back to the early days of the C programming language. So originally the C language had a linter because C is already a hard enough program. So the C language has got problems. See, lint is a linter. Okay, it's a static code analysis. It's a program that you run your code through that says, are you sure this is what you wanted here? This looks like it might be a mistake over here. Are you positive that you really meant to do this? It looks for things that aren't officially errors, but things that you maybe didn't really mean to do. So they look for stuff in your program that shouldn't be there. The original linter was written for C, okay, because C is enough of a weird language that it needs a linter. Java doesn't need a linter. There might be a linter for Java. I don't even know if there is one because Java is well designed enough that I don't even know if you really even need a, yeah, is there a linter for Java? I don't, Java, yeah. You don't really need a linter for Java, okay? Now, JavaScript famously needs a linter because the language is so poorly designed that, you know, professional JavaScript programs always pass their code through a linter because of all this weird things that you have to worry about. You have to worry about this kind of stuff. And Python too. Python needs a linter because of this kind of stuff. Declare a variable, thousands of lines later, you want to assign to that variable and you misspelled it. And since the variable does not need to be declared, in fact, in Python, even if you declare this, you've got a problem. Because this guy's declared officially, but this still creates a new variable. If you do this in a Python program, by definition of the language, that creates a variable with that name and gives it the value 5. And the Python language will not warn you that you've got another variable that looks a lot like it and that maybe you made a mistake here. Now, a linter does that for you. The linter would say, okay, now Python is trying to move away from this. The Python, for example, in the Python language, you can tell the Python interpreter to act in a more modern way, in which case this thing will, it'll drop the part of the language that lets you declare variables on the fly. So you can turn, if I remember right, you can turn that off in the language, but you can't count on that. Yeah, because that's not part of your program. That's part of the way you run the program. Your program might still have a bug in it. It's just the bug shows up if you run it one way, and it doesn't show up if you run the program a different way. Okay, so declaring a variable by just assigning to it is very bad. Okay, declaring a variable by assigning, but Python does it and JavaScript does it. They both declare variables by assigning to them. And that was meant to make the language easier to use, but it actually makes things in the long run harder to use. Okay, so assignment and declaration should be separate from each other. And if you assign to something that's not been declared, you should get an error message. Okay, that's the way our language is going to work. That's the way a modern language should work. You have to explicitly declare the variables. And you can declare the variables, you know, Java uses type. Python and JavaScript and many languages, there's var. Then there's, what is the other one? Let. Then there's val. Okay, so here's, if you look around the modern languages right now, there are a whole bunch of keywords used for variable declaration. Int, var, let, val, const. Java uses types along with C and C++. Okay, they use types. JavaScript uses var and also uses let. Okay. Scala uses, I think, var and val. Several languages use let. Haskell uses let. Okay. So let is a variable x is 1. Let x be 1. The value of x is 1. X is the constant one. Okay. Now notice, and then there's set. Some languages use set for assignment, and some languages you just assign. Because there's a little bit of redundancy. This and this are a little bit redundant. Okay. So set X equal to 1. Okay. So yeah, you don't really need that keyword. Okay. So there's a redundancy there. So a lot of languages are happy to go with just assignment. Though the trouble with that is it looks an awful lot like, well, this makes these guys symmetric in a sense by saying you let X be 1, that declares the variable, but you set X, that means you're explicitly updating a variable that exists. Okay, so some languages use the keyword set for assignment, and some just use equal sign. Okay, most languages do not have all of these. Okay, yeah, either they use one or the other. Like I say, JavaScript is weird because it lets you use these two along with the bad one of just assignment is declaration. Okay, that's the bad one. Okay, that one is very bad. Okay, that's declaration by assignment. Okay. JavaScript has declaration by assignment, declaration by var, declaration by let, and declaration by const. Okay, that's more than it needs. Okay, so some languages, like actually Java actually has this one now. In Java, this is redundant because that's a int. So notice there's kind of a redundancy there. Okay, since that's an int, you don't need to say int there. So they now let you use the var keyword, and then they infer the type of X by what you put over here. Now, in Java, the difference between that is in Java, you're allowed to say this. You can't say this. What's wrong with this?
Doesn't know
Java
what to infer.
Yeah, it doesn't know what to infer. Yeah, this says X is an int, but it doesn't say what value to put in it. So it defaults to putting 0 in it. But this says X is a variable. Since it doesn't give it a value, the compiler actually has no idea if you want it to be a bool or not. If you do this, then it infers that X is a Boolean. So when you use the var keyword, you have to assign. When you use the int keyword, you don't have to actually assign anything. You just get the default value. Okay. So, but this is a recent addition to the Java language. The Java language now lets you just say var X, and then it infers the type from the value, but there must be a value. You're not allowed to just do that. If you notice that there's a lot to say about variable declaration, I can go on for like an hour or two talking about all the ways languages nowadays do variable declarations. Just as something as simple as variable declaration is getting to be quite tricky. Java now has what we call type inference, so it lets you do var. Java doesn't have let yet. I think C# may have let. I think C# may have let in it. Okay. So lots of different ways you might declare a variable. Okay. This clearly means that that's not really a variable, it's a constant. All these others are meant to be a variable. Okay. Well, no, I take it back. See this one? Usually, this one is a synonym for this one. The languages have this. They treat it as a synonym for that. X is the value one, and you're supposed to think of it as that value not changing. So most of the time when a language has the val keyword, it's using it as a synonym for the const keyword. Okay. So these two are usually the same meaning, usually. they mean declare a variable that's not a variable. Declare, if this thing's a variable, but it's not a variable, what should you call it? When something names things, but it can't change it, so it's not a variable, what should you call it?
Is it an object?
No, objects are kind of value. Objects are the values that the variables point at. Does anybody know another word for variable? The fancy term is identifier. It's something that names something. X names one, but it's not a variable. In fact, the word variable is a bit of a problem. Not all variables are variables. Okay. In a language that allows this, they usually say that X is an identifier. X is an identifier, not a variable, because it can't change values. It can't vary, so it's not a variable. So these are variables, and these would be identifiers. Some languages don't even use the word variable. They use the word identifier to mean anything that names something. Some languages try to be very precise about what they're talking about. So they actually avoid the word variable because some identifiers are variables and some identifiers are not variables. For example, an example of that is when you do class string, blah, blah, blah. That's not a variable. It's a what?
Object.
Nope.
Oh.
The word string here is not a variable.
Oh, I see what I thought you meant.
That word is acting what? It's a identifier. What does it identify?
The type of the object.
Yeah, the type of the object. So string is the name of the type. So it's an identifier. So there's a name that's not a variable. It's an identifier. Okay. There's a lot of places in the language where you have names that you get to pick. I mean, I can call my class by any name I want. Class Jane. Okay. Jane is a name I picked, but it's not a variable. Okay. That would be what we call an identifier. Okay. It identifies that type. It's the name for that type. Okay. So a lot of languages don't even really use the word variable. They think of anything that's a name you choose as an identifier. This is an identifier of a variable. It's an identifier of the variable that can change values from one to anything you want. So this is an identifier of a variable. This is an identifier of a constant. This is an identifier of a constant. This is an identifier of a type. Okay. We have all kinds of words for this stuff. When you dig deeper into programming, you see that people have very precise language for things like declaration, assignment, variable, identifier, declaration versus assignment, variable versus identifier. And the more names we have, the more precise we can talk about things. It's kind of dumb to call that a variable. It doesn't vary. Once it's set to 1, it can never change. So why would you call X a variable? It's confusing to call it a variable. That name is not a variable name. That name is a class name. So I refer to it as an identifier. Okay. All right. Now let's go look at the language that plays around with this stuff. Okay. Let's go look at our language. Let me clean up. I hadn't cleaned up from my last class. I still have things open from. I don't even know what that folder is open in. Okay, I'll delete it some other time. stuff left over from my previous class. Okay. All right. So let's. Okay. Now, language 4 is the one that's got the language 4 uses there, and it uses it ambiguously to mean sometimes create a new variable and sometimes to update a new variable. And this is the language where you have to in the interpreter decide which semantics to give there. So in this language, there's actually two different ways of defining what there really does. When you get to there, that's the example you were looking at a minute ago. It leaves open the problem. Yeah, it leaves open this, x equal 1, create a new block, x equal 2. What do you mean? Update the current x or create a new x? In our case, we're using the var keyword here and the var keyword here, but you still have the problem. What does this line do? This line can be defined to mean create a new x in that block, or it could mean to update that x in the previous block. Whereas this var y equal 0 creates a new variable because there isn't a y to update. So since we're in a new block, you create a y in that block. Okay. And then when that block ends, this y disappears. If this created a new x, the new x disappears when you get to the end of the block. If this updated the previous x, then the x down here is still the same x, but it could be 1 or 2, depending on whether this created and then destroyed an x, or if this updated the previous x. Those semantics are not obvious, so that has to be chosen in the language. You have to say whether the var, what do you do when you get to an inner block? Do you override the outer block, or do you declare a new variable? Do you override it, or do you update this guy or declare a new variable? Okay. Language 5 is going to have two keywords to distinguish between these two ideas. So language 5 has a var and a set keyword. So that lets us go down over here and say, oh, I want to, well, now that means create a new variable. So now there's two x's. And this means update the x up here. So now this x is 2. So now I instead of making a decision in the design of the interpreter, I let the programmer decide what they want to do. I have two keywords. One keyword says update a currently existing variable, and the other keyword says create a new variable. And then if I use set here, it's an error because there is no y to set. Okay, so you can't create a variable. Set does not create a variable. Set only updates a variable. So this would be an error here. Okay, and it would also be an error right now. This updates that x, not that one. Okay, so this updates that x. It's an error to redeclare x. Not that there's anything really inherently wrong with that. It's just considered a bad idea. So most programming languages do not let you declare a variable 2 times. Okay, because it's probably means it very well means you made a mistake. Why would you redeclare x? Okay, so if you want to change x, create a new variable. There are a few languages that let you do this, and what they actually do is create a second x in the environment, and that's the current x. So that if you in the languages that let you do this, they actually will say, okay, here's the old x, here's the new x. They both disappear when you get to here. And then this is the older x. Most languages think it's bad to let you redeclare a variable. Java doesn't let you do it. C doesn't let you do it. I don't think Python or JavaScript, very few languages let you do this, redeclare a variable. Okay, so that's an error. If you really meant to if you just wanted to change the value, you should say set the variable. Set x to be 7 now. Okay, so there always creates a new variable in the current environment. So this would be in the global environment. This would be in a local environment. Okay, so var always creates a new variable, and set updates a variable if it exists. And it'll update, it'll update either a local variable. Okay, for example, okay, this is legitimate now. That updates the variable in the global environment because that's the only x around. That puts a new x in the local environment. That updates the x in the local environment. Okay. At this point in the code, here's an interesting question. Could you, at this point in the program, should you be able to change that x? See, here I can change that x, but once I've shadowed it, then this changes that one. Should I have a way of changing this one? Most programming languages say no. If you've shadowed a variable in the local environment, you cannot get to the variable in the outer environment. But some languages create a funny syntax for it. Some languages have a funny syntax for saying something like set, I don't know, I'll just use something like this, .. /x, like in a file system. Go up one level to x. Okay, no, this is actually used in the file system, but you can use it here to imagine go up one level and set the x in the upper level to be 1. I don't know of any language that lets you do this, though I think they have existed in the past. There have been languages that let you reach back to a previous level and set a variable, but it's considered like not a good idea. So Java, all the modern languages, none of them do this. None of them let you, once you've created a local variable that shadows this outer variable, you lose access to the outer variable until the local scope goes away. And then you get back to that variable there. Now, got to be careful. In the Java language, if I call this a static variable, then the way I get to it here is by doing class name dot. That goes to the class variables, the static variables. So in Java, you have this dot notation, which does let you go to it, but it doesn't go to the outer level. For example, if, see, the static variable would be up here, and then if I had, say, this thing nested in here, this doesn't go up to this. It goes straight to the global variable up here. See, so it does not let you escape to an outer block. It only lets you go to the outermost block, which is where the static variables are. So it's an escape mechanism, but a subtle one. So this hides this. This hides this. This mutates this one. This lets you escape up to the global x, but only up to the global x. You still don't have any way of getting to this one. Okay, you don't have any way of getting to that one there. Okay, so Java has things like this that let you access the static variables, which are, you can hide, like this hides that static variable. Okay, so in this x could only be that static variable. So by default, this x is the static variable. Then this one hides the static variable and creates a new x. Then, okay, so say set. Okay. This would be the static variable because that's the only x in sight. This creates a new x that's local to this block. This updates that x. This creates a new x in that block. This updates that x. And then this one lets you jump out a couple levels to the top level to get to the static variable. So here, like here, it's optional whether you want to put the name, class name here. Since that's the only x in Java, it's optional whether you put class name .x here or not. Yeah, the only x so far is that one. So here you don't have to put the class name. But if you put the class name here, then it becomes that x. So those are the scoping rules of a language like Java. The scoping rules are actually pretty complicated. There's a lot going on. You know, like no language that I can think of that's modern language lets you jump from this block back out to that block. Okay, I don't know of anything that'll let you go out one block, but it is common to be able to jump out to the top level by using something like this, like using this dot notation. That lets you jump to the top level. Okay. Or another example of that would be if this is an instance variable, then you could use the word this here. That's another thing that would let you jump to the, so if this was an instance variable, not a static variable, but an instance variable, then the keyword this is the keyword that lets you jump out a scope to up here. Okay, so I could have two x's here. I could have static x and instance x, and I could set the instance one and the static one. I access the instance one with the keyword this, and I access the static one with the whatever the class name is. Class name .x accesses static variables. This .x jumps you out of your scope to the instance variables. Now, the static and instance variables are both at the top level. In a class, if I was defining a class here, in a class, the static and instance variables sit at the top level. They're inside the class, but not inside anything else. So you have static variables and instance variables sitting at the class level. If you're inside nested blocks, this keyword jumps you up to here to the instance variable, and the class name dot jumps you up here to the static variable. Okay. So Java, JavaScript, Python, every one of these languages has its own notion of these different layers of scoping and different ways of accessing the scoping. Okay, so our language over here is going to have, doesn't have instance variables, doesn't have static variables, doesn't have global variables. Okay, it's got just two kinds of, it's just got one kind of variable. Well, it's got two kinds. There are global variables. Global variables are the variables you declare before you have a begin. Okay, so when the program starts up, see, when you have a program, that's, if you have a var here, that's a global variable. Yeah, so the global variables are the variables that belong to the program. Then inside the program, you could have a begin statement that begins local variables. So the local variables sit inside a begin. So there's global variables that sit inside of the program, and then there's local variables that sit inside of begin. So an example program would look like program var x3. Okay, there's a global variable. Okay, and here's another global variable. Okay, now begin in a local environment. So that's like having a brace. Okay, there's a local variable. Now here's a variable that hides this local variable hides that one. So if you now add, say, y and w and x, y is that one, w is that one, and x is that one. Okay. Okay. So these are local variables. These would be the global variables because they're at the top level. Okay. And then you could have another begin here. You can create another block. Okay. And you could have another. You could have a var x here that now hides that x. Now, once you've hidden that x, you can't see, if I use the variable x, it's that guy. I've lost access temporarily to that guy. Until I close this block, I don't have access back to that variable. Okay. Similarly, if I var y9, that y is that one. At this point, I have no access to that y because this one hides that one, and this one's hiding that one. You know, if you wanted to cook up some really weird notation, you could create a notation to say go out one block, go out one block. Nobody thinks that's useful. I don't know of any language that lets you do that. Okay. The only thing that that might be useful would be to have a notation that goes to the global variables, like this notation that lets you jump to the instance variables and the static variables. But it's probably not worth it. Okay, it's probably not. This is needed because it's an object-oriented language. The reason for these is because Java is an object-oriented language. So you need this kind of stuff for the object-orientedness of it. This is not an object language, so there's no real reason to be able to jump from this block and reach out to this block to access this y that's hidden by that y, or access this y that's hidden by that y and that y. Okay. Now, when you close a block, okay, now that x and that y are gone. So now if you do x and y, x is back to being that x, and y is back to being that y, but not that y. Okay. Okay. So, and then if I close it one more time, okay, if I say print y, okay, I'm back to that y. Okay, this y was that y, but then I closed that begin, so now I'm back to the global variables. So that y is that one, because the scope, see, that scope ended there. Okay, so this y, we think of it like this. Sometimes people draw pictures like that. That's the scope of y. Now notice that y doesn't exist before this line. Okay, if I did print y here, that y is this one. This y goes up to there. So that y is not this y. Now, JavaScript makes a horrendous muddle of this. JavaScript has this notion of what's called hoisting. And in JavaScript, this y is that y. That y becomes that y because that y is hoisted up to here. JavaScript makes all this stuff nightmarish. Okay, so in JavaScript, you actually have this weirdness that this y wouldn't be that guy. It would be this guy because this guy is in this block and this guy's in the same block. So this guy is that guy. Okay. Most people think that's a bad idea. It's not clear why JavaScript even wanted that. Most people agree that it's a mistake in JavaScript to act this way. Okay. I should switch notation. I'm using, yeah, there's print. And I'm bouncing between different notations. In our language, print looks like that. Okay, we're using a tree language. Okay. In JavaScript, that guy is that guy. The scope of this declaration begins in its block. So even though y is declared at this line, it exists even up here, but it doesn't have a value. When you print y, it'll be undefined. It's this y, put this y before it gets a value. So at this point, you can try it in JavaScript. You'll see that it will print undefined. It will not print 4 like you would think it would. Like, that y won't be that y. It'll be that y, but that y hasn't been assigned yet. So this y is undefined. JavaScript makes a real muddle of this stuff. Okay. What we're talking about here is called lexical scope. The scope is determined by, once a variable is declared, then the lines of the page up to its enclosing block, that, the definition is, once a variable is declared, it's declared up until the end of the block it's in. Okay. Oh, let's see. That was, yeah, this variable goes up to there. That's called lexical scope. The scope of a variable starts at its declaration and goes up to the end of its block. Okay. This y starts at its declaration and goes up to the end of its block. We call that, and then it hides the y that's out. Yeah. Oh, and then I actually have to be very careful about saying this. See this y here? I said that it goes up to the end of its block, but then it has a hole here. This y starts hiding that y. That y exists, but you don't have access to it until you get back here, and then this y is back to that y. Notice it's actually kind of complicated. So the scope of this y is from here to here, but we say there's a hole in its scope because this y here starts hiding it. So then this y hides that y for a couple lines, and then this y is back to being that y because this y went out of scope at that line there. The system's called lexical scope, and it's what Java, C++, it's what Python and JavaScript more or less kind of try to do, but they muddied it up. They were meant to be lexical scope languages, but they did a really bad job of it. So C, C++, and Java are lexically scoped languages. Python and JavaScript are messed up lexically scoped languages. Okay, they don't do a very good job of this. Okay, so begins a new environment. There puts a variable in the current environment. Set, I didn't use any sets here. Set changes the value of whatever current variable is in existence. So if I do something like set y5 here, it sets that y. But then if I do set y19 here, that one sets this y. Okay. And if I say set b to 0 here, I get an error message. There is no b anywhere in the program. Okay, you can't set a variable that's not been declared. That's an error. Okay, so it's an error to set a variable that hasn't been declared. Okay, there creates a variable, set updates a variable. There creates a variable in the current block, set updates whatever variable is available. If it's in the current block, fine. What x do we have available? We go back up here and say, there's the next x. See, as I started at that x and I went back up, the first x I got to was there. So that's setting that x. You can go, if you go, when you ask for a set, you kind of go backwards. Set that y. Set, that's a print, so that's not a declaration. That declares w. Oh, there's the Y, there's the declaration. Set that Y. So you kind of go backwards with sets and ask, who's the first variable declaration? You know, there's the variable, go back to look for the first declaration of it. That's what you set, okay? So set X, you look for an X, you look for a declaration of X, and it's that one there. That's what we call lexical scope, okay? Now, how do we do this in the interpreter? Okay, so what do we do to change language 4 to make it act like this language 5? Okay, let me just save that. Okay, okay, so we have to, what we do, if we go to the interpreter for language 5, the interpreter is the evaluate function. It's got, well, the definition of begin doesn't change. Begin just creates an environment. So language 4 to language 5 doesn't change the behavior of begin. It does change the behavior of var. Var is going to act differently than it used to. For example, the old var could change a variable. The new var only creates variables. It never changes a current variable. And then there's this new set. So essentially what we're going to do is we're going to take the var. If we go to language 4 and look at its evaluate, what this var did, the code for it's going to essentially be split between var and set. What it really amounts to is the code that was in this var is now going to be more or less split evenly between part of the code going to set, the part that does an update, and part of the code going to var, the part that does a declaration. Because this var did both. It could do an update or a declaration. It could create a new variable or update an old variable. So now we're breaking that up into two keywords, one specifically for updating and one specifically for declaring. So the code's not going to be much different. So if we go over here and we look up evaluate var, okay, there's evaluate var, okay, from here to here. And you know, it basically, well, first it did all this type checking, error checking. There should be two branches to a var, okay? If you don't have two branches, something's wrong. The left branch should be a variable. So grab the left branch and check that it's a legitimate variable name. Okay, this code here will be in our new var and also in our set. They'll both begin exactly the same way. When we go over here, the new var and set are both, they have exactly two branches, and the left branch has to be a variable with a legitimate syntax to it. So the new var and the new set will both start off exactly like that. Okay. And then actually it's going to be the same all the way up to here, because then the next thing is get the value of the other part of the expression. There's a var and a set both have a variable and an expression, a variable and expression. And the same thing in language 4, a var had a variable and an expression. So you need to get you need to check that there's two branches. Then when you're sure it's two branches, get the left branch, make sure it's a variable, and evaluate the right branch. So that code is the same for set and var. Check there's two branches, check that the left branch is a legitimate variable name, evaluate the right branch. After you've done all those steps, then you have to start deciding whether it's a var or a set. So this is language 4. After doing all this, then here's the part that figures out what to do. Okay. If the variable is defined locally, if it's not defined locally, we are creating a new variable. If it is defined locally, we're updating it. That's what this language did. Then if you change that thing here, then you get the other semantics. Okay. So now go over here to this language and look at how var and set vary. You know, one will be doing the updating and one will be doing the declaration. Okay, so here is evaluate set, and below it is evaluate there. Okay, this much code is exactly the same. No, I'm sorry. Oh, I didn't really write them in the right order. I did. So, okay. I juggled the order around a little bit. So the same, I didn't keep the code in exactly the same order. So let's look at what set is doing. Check it's got 2 branches. Okay. Get the left branch. Make sure it's really a variable. Okay. Now it does a little extra step. That it says, if I'm a set, I have to set something that's already been declared. So once it gets the variable name and checks it's really a variable, it makes sure that it is defined. Otherwise, you're setting an undefined variable. So it does a little test right away. Language 4 didn't need to make that test because language 4 was saying, if the variable exists, we set it. If it doesn't exist, we declare it. Set will not declare a variable. So if you try to set an undefined variable, it should throw an error. Okay, so check there's 2 branches, get the variable name, make sure it's a proper variable name, make sure it's been defined already. Okay, if it's been defined, now we're ready to evaluate the right-hand side. So there's no point in evaluating the right-hand side if you've got an illegal variable name. See, that's why I changed the order a little bit. Don't evaluate the right-hand side. If you look at the syntax, there's no point evaluating this if this is an illegal variable name. Okay, so make sure this is a legal variable name. That's just an efficiency thing. There's no point evaluating this if this thing's an illegal variable name. So we should do things in the most efficient order. So we check that this is a legitimately declared variable before we go and bother to do the work of evaluating that expression. Okay, so make sure it's a legitimately declared variable before evaluating the right-hand side. Now, when I've got the value, I just update the environment. Take that result, take that variable, update the environment. Okay. All right. Notice that in this code, runtime check, runtime check, runtime check, do the work. If this was a compiled language, all this could be done by the parser. This could be done by the parser. This could not be done by the parser. This one's tricky. Okay. Obviously, the parser could tell if you have 2 branches or not. Obviously, the parser could check if the variable name matches this pattern here. It's a legitimate variable name. It turns out this one's harder. Checking that the variable has been declared before you set it. That can be done by the parser, but it's much harder. And that's actually going to be one of your homework assignments later in the semester. I'm going to show you how to do that. You're going to do that as a homework assignment. You can do this step before the interpreter in the parser, but it's a little bit tricky. And it's an interesting homework assignment. Okay, you might think about it. How would you know if a variable's you're not going to come up with an answer real quick. But the question is, how can you know if a variable's been declared without running the program? Is it possible? Can you tell if a program's been declared without running the program? And the answer is yes, because of this picture here. Essentially, when I get to that set, notice that I don't have to run the program. I can just go back and say, look, there's the variable X. See, we call this we can do this statically. We don't have to actually run the program. Does that X exist? Yeah. See, there's a way. Now the question is, how do you do this algorithmically? Now, on the other hand, if I do set Z 0, well, no Z, no Z, no Z, no Z, no Z. Oh, I ran out of code. That's an undeclared variable. See, you can see how it makes sense. You don't have to run the program. You just scan the code lexically. That's why we call this lexical scope. You just scan the code lexically. If you get back to the end of the code and you never found the variable, it's undeclared. Okay. Now, making that an efficient algorithm is tricky. Okay, that's one of our goals. Like that it can be, we can see it can be done, but then the question is, how do you make that doable? How do you actually do that in the code? And I'll show you in a homework assignment a way to make that work. Okay, so we can convert this to a right now it's a runtime test. Okay, this is a runtime test. Okay, I'm checking at runtime if the variable's already been defined. I could eliminate this test here from my runtime if I write my parser to do something real clever. In fact, we won't put it in the parser. What we're going to do is we're going to have a step between parsing and interpreting. Later in the semester, we're going to put what's called, remember when I pointed out this code here, the linter is something called a static analysis, static code analysis. Static code analysis is something you do after parsing and before interpreting. That's what static code analysis is. It's something that's done between parsing and compiling. And we're going to add a static analysis step to our language, and that's where you can look for undeclared variables. So we'll add static analysis. That's a step between parsing and interpreting, or between parsing and compiling. It can be done in either one. Okay, but it's actually a step that comes after parsing. So JavaScript linters, they parse your JavaScript, then they analyze it. They parse it into an abstract syntax tree, and then they analyze the abstract syntax tree. And that's what we can do. We'll see a clever way to find undeclared variables by parsing the program to an abstract syntax tree, and then doing a walk of the abstract syntax tree that essentially does this trick of saying, is there a way to tell if this variable's been declared or not? Okay. Okay. So that'll be a programming assignment later in the semester. You'll write a baby static analyzer. And believe me, static analyzers are a big deal in computer science. Understanding what static analysis is it's a nice homework assignment, because it gives you a hint of what's really going on in these sophisticated tools like lint. And static analysis has become the go-to way to find, for example, security problems in programs. Okay, you don't want to run a program to find out that it's got a buffer overflow. You'd rather analyze the program. So static analysis has become one of the key ideas in trying to find security problems in programs. We won't get anywhere near that far, but you're going to write a baby static analyzer. But that's actually one of the reasons why static analysis is such a big deal these days. It's become one of the key ways to discover security issues in programs. There's all kinds of companies out there trying to write more powerful static analyzers that can find more security errors. And they can make a lot of money by doing that. If they can write a really, really powerful static analyzer that finds lots of security errors, it's worth a ton of money. There are some open source projects that do that, but there's also companies doing that, because there's a lot of money to be made selling that software, because security issues are just very costly. So people are willing to spend a lot of money to solve security issues before they become even more costly when they become a problem in code. Okay. All right. So we're almost done. So that was set. Okay. So now let's real quick look at var. Now var creates variables. Check that there's two branches. Get the variable name. Make sure it's a legitimate variable name. Okay. Now you can't redeclare a variable. So var does the same thing that set did. Var wants to know, now set said, if it's already declared, that's a mistake. Set wants the variable to have been declared. Var wants the variable to not been declared, because you can't redeclare it. So this check in var is the opposite of the check in set. Set requires the variable to already be there. Var wants the variable not to be local. The variable can exist, but you can't redeclare a local one. So see, this one checked that the variable exists globally. This one checks that the variable doesn't exist locally. It wants it to not be declared locally. Okay, so that's a runtime check. Make sure the variable's not being redeclared. Again, that could be lifted to a parse time check with a static analyzer. This is another thing that could be fixed with a static analyzer. Okay, if the variable has not been declared locally already, everything's good to go. Grab the right branch, evaluate the right branch, add the variable to the environment. You're done. Okay, so all this is checking up here. Everything up here is checking. And then after you've done all the checking, then you can do the work. And same thing here. I mean, same thing with set. Pretty much, majority of this is checking that could be done at parse time. All those checks could be pretty much done at parse time. Once you know everything's okay, then you just do the update. This one does the update. This one does the add. Okay, see, so set only does update, var only does add. If you go back to language 4, notice that language 4 sometimes did add, sometimes did update. The var in language 4 did both add and update. Now, var only does add and set only does update. So we've separated the concerns and we got a cleaner language. Okay, so language 5 is a cleaner language. It's more like a modern language. It separates the declaration idea from the assignment idea. Okay, so it clearly separates assignment from declaration. Okay, but language 4 is nifty because there are languages like this. You know, that's not it's not an unreasonable design for a language. It's not considered a good one by modern standards, but there are languages that out there that have been like that. I mean, JavaScript is kind of close. JavaScript is somewhere between language 4 and language 5. In JavaScript, the way it works is not like language 4 and it's not like language 5. It's kind of a weird blend of the two, a really messy, kind of dumb blend of what language 4 does and what language 5 does. That's bad. Okay, but that's how JavaScript works. Okay, so let's see. Next week we'll go to the next language. Next language is going to give us if statements and for loops. Okay, so we're going to start looping. We've done this. We've got enough variable declarate. We've now got a language that declares variables properly. So we've got proper lexically scoped local and global variables. And the next step is to start letting us do looping and if statements and then functions. Okay. All right. So run out of time. Anybody got any question about what we talked about? Any question? Okay.
Oh, I have one quick question.
Yeah.
So is scan like trace back, or are those completely different
I'm not sure. What do you mean? What's
concepts? I don't know. I was when you were talking about searching backwards through the program to the beginning to see if
yeah.
the variable.
Oh, no. Yeah, when I said, oh, no, we will not literally search back this way. That's a dumb way to do it. We'll do it a much more clever way. Okay. What my point here is that you could tell that there's an algorithm. So you can just say, I don't need to run this program. I just need to go backwards. And if I can find that variable in a declaration, I'm good. And if I can't find it in a declaration, it's not declared. But we will not scan backwards like that. That's a dumb way to do it.
Okay.
Yeah, it shows you that there's an algorithm, but it's a really lousy algorithm. So we'll find a better algorithm that's more clever, that's easier to code, and yeah, we'll do it a better way. Okay, so we will not just, we won't say, oh, every time I do a set, I have to go back through the code to see if the variable exists or not. Like that one stops right there. This one stops right there. Yeah, but that's a bad way to do it. Okay, so when we get to that homework assignment, then we'll go back to this idea and I'll show you a much cleverer way to look for undeclared variables. And it isn't going to be scanning backwards. Yeah, that's just, if the code was 10,000 lines long, that just doesn't work. That's really inefficient. It would probably be hard to write. Yeah, how do you work your way backwards through a program? Yeah, but it gives you a proof of concept that there is a way to tell that the variables have been declared or not without running the program. I don't need to execute this. And that's important when I have for loops. You know, if I had a for loop in here, if I had to run the program to find the undeclared variables, I'd have to wait while every for loop iterated a billion times. The fact that I can do this by just scanning the code means that I can scan right over for loops without executing them. The key is I don't want to execute the for loops to find out if there's undeclared variables. I don't want to execute the code. I just want to look at it. And we'll see that you can, that's called static analysis, analysis that you can do without running the program. In general, whenever you see someone say static, oh, the word static is overloaded like crazy in programming. Yeah, remember I talked about static variables. This static and this static are not at all the same thing. The word static is horribly, ridiculously overloaded in computer programming. We use the word static in too many different ways. And this static, as in static program analysis, has nothing to do with this static, as in static variables. This is kind of a weird way of declaring a global variable. This is saying you can determine something about your program without running the program. You can determine, it's what you can determine at parse time. Static analysis would be better called parse time analysis. What can you figure out the program while you're parsing it, or right after you parsed it, but before you compile it or interpret it? That's static analysis, meaning what can you tell without running the program? Or another way to put it is, what can you tell by only parsing the program? Or another way to put it is, what can you tell about the program from the abstract syntax tree? Yeah, what can you discover using the abstract syntax tree without running the program? Okay, so that static is completely different than this static here. Okay, so we'll do that then later in the semester, and then we'll see how to get rid of a lot of these runtime tests in the interpreter. Okay, any other question? Okay, if you have questions about the homework, I have office hours tomorrow afternoon, and you can always send me email, and okay, I'll go ahead. Have a nice weekend, and see you on Monday. Okay, bye-bye.